digital.
December the 25th, Christmas Day, very few people, I suspect, knew what a tsunami was.
All I could see was a wall of water. You know, the sky was blocked.
Coming again!
It was just something out of a science fiction book.
Unfortunately, now, virtually the entire population of this planet knows what a tsunami is and the horror that can strike from a tsunami.
It's a huge catastrophe, most widespread devastation that we've seen from a natural disaster for centuries.
It's like the aftermath of an atomic bomb, is maybe worse.
The tsunami of December 26, 2004, took the lives of at least 250,000 people across more than a dozen countries. It's early morning, December 26, 2004. Southeast Asia awakes to what should be another ordinary day. Fishermen are on the water in Sumatra. In Sri Lanka, 1,500 people take a train along the coast. Among them, a tourist named Shent Ravindra.
I was going to do some scuba diving around the coral sanctuary. My dad was very keen for me to catch the train because of the beautiful scenery that I would encounter on the way down.
In Thailand, Tom Travers and Richard Anthony opened their beachfront restaurant.
I went down, put some laundry in, which we came back, ordered some breakfast through. Yeah, it was just another normal day, basically.
And in Hawaii, scientists at the Pacific Tsunami Warning Center carry out routine tests of their equipment. All these people are unaware they are about to be caught up in one of the worst natural disasters ever. It begins shortly after dawn and without warning, when a huge earthquake tears apart the floor of the Indian Ocean. The Earth's crust is divided into giant rafts of rock called tectonic plates. The plates are always on the move. When they collide, enormous amounts of strain build up. Where the plates grind past each other, earthquakes occur. Under the Indian Ocean, one plate is pushing beneath another in a process called subduction. It's been doing this for 40 million years. On December 26th, something snapped.
The Indo-Australian plate is what's called subducting beneath Indonesia. It's sliding beneath the plate that Indonesia is situated on. That interface has what's called stick-slip frictional properties, and that means it drags the upper plate down with it. And it pulls it down and deforms the upper plate, builds up strain energy. Eventually the stress on that contact exceeds the strength of the contact, and the upper plate snaps back into position.
The Earth is 155 miles from the Indonesian island of Sumatra.
The rupture, the fault that actually tore in the Earth's crust is about 1,200 kilometers long.
The continental plate shoved out over the oceanic plate by about 10 to 20 meters. Most of the motion was horizontal, but some was vertical because the plate boundary, the fault, is inclined.
Most of the energy travels perpendicular to the strike of the subduction zone. So it more or less went east-west, towards Sri Lanka to the west and towards Thailand to the east.
The earthquake continued for about 4 minutes. Soon after it ended, this seismogram recording the event appeared in California, 8,000 miles away. It will be several hours before analysis will confirm at least a magnitude 9, one of the most violent on record.
For every unit you increase in magnitude, you go up about a factor of 30 in the radiated energy. So it would take 30 magnitude 8 earthquakes to match the energy of a magnitude 9.
In Sumatra, the city of Banda Aceh feels the full force of the earthquake, and buildings collapse. It's more powerful than all the world's earthquakes over the last 5 years put together. Halfway around the world in Hawaii, a few minutes after the earthquake, computers at the Pacific Tsunami Warning Center spring to life as they pick up seismic signals. The Warning Center was founded in 1949 after a tsunami struck Hawaii, devastating the town of Hilo and killing 159 people. Today, the Warning Center operates around the clock, monitoring the Pacific Ocean for tsunamis. In any earthquake over magnitude 6, scientists on duty are automatically paged.
I just fed my cats. I was lying down for a kind of a nap. It had been 3 or 4 days I've been on duty already. I was on the verge of falling asleep when my pager went off. I looked at the pager very briefly. I could tell from the message that I was dealing with something probably larger than a 6, and I was here within about a minute. And Stu Weinstein was already looking at them.
But I noticed that the trace of this seismic area was very full. It appeared as kind of just like one thick line going across the screen, and that told me that it was a substantial earthquake.
To detect and pinpoint earthquakes, the Warning Center relies on data from a network of seismic stations. But not all earthquakes spawn tsunamis, so they use coastal tide gauges and deep ocean pressure sensors to figure out if one has formed. Located on the ocean floor, these sensors monitor the depth of the water above them. A change could mean a deadly tsunami is passing overhead. Data is relayed to a buoy on the surface, up to a satellite, and down to the Warning Center. There are 6 of these sensors in the Pacific Ocean. This system has saved countless lives, warning countries around the Pacific of killer tsunamis.
Poses a serious threat.
But in the Indian Ocean, there is no such system, and no warning center, although seismic sensors do exist. In the first few minutes after the earthquake, data from these seismic stations alerts Weinstein and Hirschhorn to its location and size, causing them serious concern.
I then estimated the magnitude at a magnitude 8. Our response was, wow, that's a fairly large event. And we issued our first official product, which was a Tsunami Information Bulletin.
The bulletin informs countries around the Pacific Ocean of the earthquake. But not all magnitude 8s form destructive tsunamis, and with no network of tsunami sensors in the Indian Ocean, they do not know if this quake triggered one.
The seismic analysis can only take you so far. We also looked at what water level information might be available, and because this was the wrong ocean, the answer was none.
We had no tide gauges, and so at this point we had no evidence that there was any waves generated.
And this was a tremendous, crippling, frustrating experience, because without water level gauges, we don't know if there's been a tsunami.
We were, unfortunately, flying blind.
As they watched events unfold, their frustration would soon turn to despair. When an earthquake occurs under the ocean, its energy can dissipate as shock waves through the crust, or as a tsunami through the water.
Whether that shock wave turns into a tsunami, into a water wave, depends on where in the Earth's crust the earthquake takes place. In this case, it took place very near to the surface of the seabed.
This earthquake was only about 30 kilometers deep, which is very, very shallow. If it had been 200, 300 kilometers down, it would not have generated a tsunami.
As the seafloor lifted, it displaced billions of tons of water above it in a process called tsunami initiation. This released as much energy as 23,000 Hiroshima-sized atom bombs.
As a result of the earthquake, part of the ocean floor has been uplifted and part has been dropped down along the fold surface. Because the seafloor changes, so does the water column above the seafloor. So some parts go up here, some parts go down.
Seconds later, the tsunami undergoes a transformation as the displaced water column splits.
The uplifted area basically collapses, and the water rushes away from the uplifted area, creating a tsunami wave that's traveling radially away from the uplifted area. The tsunami wave's now speeding off to some distant shore at 1,000 kilometers per hour.
The main pulse can cover the ocean quite rapidly, which means that in the initial few minutes, the northwest part of Sumatra would have been hit.
In Sumatra, 10 minutes after the earthquake, people are unaware that an enormous wave is charging toward them at over 500 miles an hour. In the open ocean, tsunamis are virtually undetectable. This simulation shows how a boat in deep water is only slightly affected. Fishermen at sea barely notice a tsunami passing under their boat. But as a tsunami nears land, it rears up into a monster, growing by a process called amplification.
As the wave approaches the land, the front of the wave slows down. It slows down to 400, 300, 200 miles an hour. The back of the wave is still going at 500 miles an hour. And the back of the wave catches up with the front. And you get this big build-up of water.
The amplifying wave can have a curious side effect. Before hitting land, it draws water from the leading edge, exposing the seafloor for as much as a mile. This phenomenon would lure thousands to their deaths.
One of the big problems about trying to prevent deaths due to tsunami is trying to stop people rushing down to the beach when the sea goes out. That happened here. People went down, they saw fish flapping about on the beach, went down to pick them up.
If you see the sea start to come out, you don't stand and wash in awe. You run.
Unlike a classic surfer's wave, tsunamis do not roll toward land. Instead, they surge forward like a flood. The leading face builds into a wall of water. Tsunamis are so deadly because the volume of water that follows is so great.
Tsunami have wavelengths, which is the distance from the crest of one wave to the next wave, of hundreds of kilometers. It will keep coming in maybe for 5 minutes or more, and it has enormous mass behind it.
People see water as being fairly soft, gentle, something fairly benign. But bear in mind that water is very heavy, and a cubic meter of water weighs a ton. So if you've got one of your kitchen units at home full of water coming towards you or falling on top of you, that's a ton of water. That's like having a car land on top of you.
The sort of waves that we've seen in the Indian Ocean tsunami of 2004 are probably able to deliver, for every 1.5 meters of coastline, 100,000 tons of water, which is an extraordinary figure. And that is coming into the coastline, hitting the coastline with incredible force.
And as the tsunami progresses, as it goes through the coast, it's picking up stones, it's picking up debris, like a tornado almost. And that debris, cars, people, being thrown at you at 40 miles an hour, that's going to hurt, that's going to kill you.
But for most people, there was nowhere to run. The water reached enormous speeds, picking up anything in its path.
The waves will break up buildings, they'll break up cars, they'll carry these things inland, and of course people will be carried for kilometres along with all this debris and bashing against it and being prevented from actually getting up out of the water by a virtual layer of debris at the top.
Evidence of the tsunami's colossal power litters the coastline.
This is what's left of the Banda Aceh cement works and the wharf area. the ship being totally trashed there. Here we've got these huge big sections of breakwater, and they've just been sheared off and thrown over here like rag dolls. And these pieces here must weigh hundreds of tons, and it just defies belief really, which kind of gives you some idea of just how awesome this thing was.
The damage to this cement factory is another indication of the height of the wave when it hit.
Just this area we've been walking around here today is like the aftermath of an atomic bomb, is maybe worse.
Under this wreckage lie thousands of bodies. About 3/4 of the tsunami's victims died here in Sumatra. Southern Thailand, 1 hour after the earthquake. Cities are waking up and beaches beginning to stir. People have no idea a massive tsunami just struck Sumatra and is about to hit them.
Just moving so quick that I bolted.
I was on the roof. I was not going to let the water take me away.
It was just something out of a science fiction book.
Well, one of the extraordinary things about...
Less than 4 hours since the earthquake, the Maldives are next in the tsunami's path of destruction. With the wave charging across the ocean at the speed of a passenger jet, it seems like a losing battle. But using their travel time map, scientists at the warning center realize there's still time to alert Africa.
We contacted our State Department and we advised them that this was a very large earthquake and there was the possibility of tsunami waves striking the east coast of Africa.
The State Department Office of Operations immediately patched us through to the embassies in Madagascar and Mauritius, and we gave them a warning.
Their embassies in East Africa would also contact people in positions of authority to try to get out some sort of warning to the East Africa coast.
The news reaches Kenya with enough time for people to evacuate the coast. There is only one fatality.